Recall that for an n by n matrix A, the determinant of A is given by this expression here. We're going to look at the determinants of some special matrices. If A contains a row or a column of zeros, for example, something like this, then the determinant of A is going to be 0. And it's not too hard to see this because remember that each of these products contains exactly one element from each row of A and one element from each column of A. So if you have a row or a column of zeros, each product will have a 0 somewhere, and so the entire product is 0. And so taking a sum of zeros, you get 0. Next, we're going to look at permutation matrices. An n by n permutation matrix is a matrix obtained from the n by n identity matrix by permuting its rows. For example, this 4 by 4 matrix is a permutation matrix. Here you can find all rows of the 4 by 4 identity matrix but permuted. As the name suggests, n by n permutation matrices represent permutations. And to construct the permutation that correspond to this matrix, what you do is you go through row by row. Say you want to look at sigma I, then you look at row I, and find the column that contains 1, and the index for that column is sigma I. So for this example, sigma 1 will be 2 because in row 1, column 2 has 1. And sigma 2 will be 4 because in row 2, column 4 has 1. And sigma 3 is 1. And sigma 4 is 3. Once you have constructed this permutation, the determinant of the matrix is simply minus 1 to the number of inversions of this permutation. And for this permutation, I have 3 inversions, 1, 3, 2, 3, and 2, 4. So the determinant of this matrix is going to be minus 1 to the 3, and that's minus 1. Finally, we're going to look at triangular matrices. A triangular matrix is one that's either upper triangular or lower triangular. An upper triangular matrix has all the entries below the diagonal equal to 0. For example, this matrix is upper triangular because the diagonal is here and everything below it is 0. And for lower triangular matrix, all entries above the diagonal are equal to 0. For example, this matrix here is upper triangular. If you have a triangular matrix, the determinant is given by the product of the diagonal entries. So for this example up here, the determinant is 1 times 0 times 4, and that's 0. And for this example down here, the determinant is 1 times 3, which is 3.